Good afternoon and welcome to SFIA. We're going to be hosting today Fraser Cain of Universe Today, one of our sister channels, and let's just go ahead and get started. Good afternoon, Fraser. How you doing?
Hey, Isaac. Doing great. What does SFIA stand for?
Oh, Science and Futurism with Isaac Arthur. We ended up with
Oh,
that title just because it was the one that got stuck on us. We couldn't think of one better, I'm afraid. So
no, that's awesome.
I suspect most of our audience is already very familiar with your show. We've collaborated before, and you've been around for quite some time doing this. But for those who aren't familiar with Universe Today as a publication, a channel, could you go ahead and tell us how that got started and what that's about?
Sure. Yeah, I started Universe Today as sort of as a side gig. I was working for as a web developer back in the '90s, and in 1999, so we're almost 20 years now. I founded Universe Today as a way to sort of stay in touch with the space news that I had been a huge fan of. I read The Case for Mars by Bob Zubrin and Pale Blue Dot by Carl Sagan, and those two books. I was just like I'd always been into space, and I picked up those two books, and they just got me completely riled up to do, some kind of space-related creative project. And so I started Universe Today as just a side project while I was doing my regular job. And within a couple of months, I'm like, oh, this is what I want to do for the rest of my life. I want to learn to be a science journalist and report on space news forever. And I was fortunately able to transition from the one job to being able to do this work full time, and I haven't looked back since. So, literally closing in on 20 years now of reporting on all the various space news that's happening.
I was surprised by that, but I've actually been tuning in or reading Universe Today articles since, I'd say, about 20 years ago.
There you go.
Maybe
You
18.
must have just been like a child or something.
Oh no, I've picked it up. I think either late in my undergrad or early grad. Would have been early 2000s though. So, and
Yeah.
it's been. I say usually it's one of the ones I recommend right along with Paul Gilster from Centauri Dream. So, if you're looking for
Yes.
good astronomy information in general, there's really no better place to get it. In terms of astronomy, I mean, we've seen it evolve a lot over the years. You were just remarking about Sagan and Zubin. I was thinking back when I first read that, for Case for Mars in the mid '90s. We hadn't discovered a single exoplanet yet.
Yeah.
And
Yeah,
I think,
I'm trying to think. 1995, Peg 51b was the first proper exoplanet, the hot Jupiter that was found. And so when you think here we are 25 years later, it's mind-bending. There are thousands of exoplanets. We have measured their atmospheres, found them in the habitable zones, planets around red dwarfs, and sun-like stars, even planets around the closest star to the sun. Like, it's such a different world now.
it's funny to think is that we've found, I think, at least 10,000 of them now, either as candidates or hard confirmations. And yeah, that's just barely scratching the surface.
And when you think about like Tess is going to find about 15,000 planets. Gaia will potentially find tens of thousands of planets. And there's all kinds of other projects in the works. The European Space Agency has its CHEOPS mission, which is going to be like a companion to TESS to find even more worlds. So I wouldn't be surprised if we had this conversation 10 years from now, we would know of hundreds of thousands of planets.
And yet we've probably got billions of them to potentially look for on interesting things on as we get down the road. It's
Lots
interesting.
more to find.
We've cataloged so many of these stars and galaxies out there, and yet most of these things, they don't ever get a name. We probably could never even give them all names without having a lot of repeats. But maybe the more important ones that we find atmospheres around and habitable zones, we're getting ready to do some launches on stuff like that. What kind of things should we be looking for? I mean, we talk about techno signatures on atmospheres of these planets, trying to hunt for them for SETI. What other sorts of things would we do with that? What would we be looking for on those planets?
Well, I mean, in terms of techno signatures or biosignatures, right? Like there's sort of two really big schools of thought here, right? This idea of like when James Webb launches, it's going to have the ability to measure the atmospheres of planets orbiting other stars and be able to look for, this is what the astronomers call biosignatures, like looking for some kind of signal that there is life there. You come to planet Earth and you see the plants around and you you see the oxygen in the atmosphere. You know that there is life. There's something that is out of balance that is generating this atmosphere here on Earth. And so the quest is to come up with a biosignature that then astronomers can find on other star systems, and then use these powerful telescopes like the James Webb to be able to locate them. It's actually a more complicated problem than I think people had expected previously. That trying to figure out like an unambiguous biosignature, something that if you said, "Oh, we see it," then that means there's life, is actually really tough. Mm-hmm. And people have proposed things like oxygen and ozone and carbon dioxide and all kinds of different methane, different chemicals, and all of these, there is a way that they could be naturally produced. But my guess is by the time James Webb launches, in the next 1,000 years or so, the astronomers will have come upon some set of indicators that says, okay, there is absolutely some form of life on this planet that is generating an atmosphere. So it's interesting to think that we are just a couple of years away now from having an instrument in space that can try to give us those sort of definitive answers. And even if James Webb doesn't do it, there are multiple telescopes following afterwards. There's a bunch of ground-based telescopes like the Extremely Large Telescope. There's some space-based telescopes like LUVOIR that will do an even more dramatic version of this. So I think that we are, I would say we're within 10 to 20 years of having the tools in place to tell us if there is life orbiting other stars in our galactic backyard. And that's just like life. That's just like whatever, slime, mold, and trees, and
trying to find something with an actual techno signature is a lot trickier. But I think
yeah. And then at the same time, I mean, NASA is taking this idea of SETI a lot more seriously in the last couple of years. I mean, for the longest time, the whole idea of SETI was seen as ridiculous, that nobody would search for any kind of evidence of alien civilizations. And yet, of course, it is easily the most important philosophical question that a human being can ask, right? Are we alone in the universe? We want to know. I always provide this thought experiment. If I could give you an envelope, and in that envelope was the answer, are there other alien civilizations in the Milky Way? Would you want to open that envelope? Would you want to know the answer to that question, right? Either way, as Arthur C. Clarke said, it's an interesting outcome.
Oh, sure.
So
the implications of what it's going to be like if there is no other life are in some ways just as staggering as finding that life nearby.
I think scarier, right? The fact that if it does turn out that there is no life, then all the pressure's on us, mm-hmm. right? Like, we can't mess it up, or at least the dolphins can't mess it up. And if the dolphins mess it up, then the octopuses can't mess it up. And if the octopuses aren't able to pull it off, then maybe it's going to be the cockroaches. And then the sun will have expanded and destroyed all life, boiled away the oceans, and then we're out of chances. But one of us has got to be able to pull this together to spread life into the universe. If it is empty, and if it's not, then we don't have to panic, right? We're like, we'll let the aliens figure that out, and maybe they'll invite us to their party.
And of course, that is always one of the concerns on SETI, is if there are all these filters that prevent life from being too common, what if some of them are still ahead of us in time?
Right, of course. Oh. Yeah, I mean, and that's, of course, that idea. You find life on Mars, you find an unambiguous signal of an alien civilization coming from another star system, and then you're like, uh-oh, right? Sounds like the Great Filter is ahead of us now, because we know that something happened to them that wiped them out, and whatever that thing is, it's going to wipe us out next. So
the problem is you can never ask them after the event without going there to find their ruins.
yeah, exactly. We should, hopefully we can figure it out. But in theory, the whole key with the Great Filter, of course, is there's no way to avoid it. That it hits everyone 100%, no matter how hard you try, no matter how well prepared you think you are. Great Filter comes for all of us. So NASA organized this Techno Signatures workshop a couple of months ago, I think back in September 2018, and brought together just some of the best minds in the industry. Jill Tarter, of course, who's one of the founders of the SETI Institute and really one of the main people behind the search. She was the subject of Contact, right? And David Kipping, the Exomoon guys, and Jason Wright, one of the people who helped uncover information about Tabby Star, and another 40 or 50 people who are tangentially working in this field, and they just sort of brought together all of their ideas. They gave each other a bunch of presentations, and then produced this really wonderful report that is all the different ways that you could search for technosignatures out there in the universe, and which are the ones that are going to be the most likely to provide some kind of result. And it's quite amazing how some of these are well along. Like when you look at things like the Square Kilometre Array that's being built in South Africa and Australia, it's going to be able to detect the leaked electromagnetic transmissions from other civilizations. Like it could detect us on Earth, not a directed SETI blast, but it could actually detect just us watching television. So we are, say, a decade away from having a tool that can just sense the background transmissions of other civilizations.
And that question comes up a lot of times is when we say looking for technosignatures. We'll talk about biosignatures earlier with atmospheres, but for technosignatures, the big low-hanging fruit has always been looking for that radio signal. And then the other one we usually do is Kardashev 2 civilizations. And we had that fun of, what was that, last year when we did the tips for engineering in Kardashev 2 civilizations. Yeah. That was a great episode to do.
Yeah, well, and this idea, I mean, that if you, no matter how advanced a civilization is, they can't hide their waste heat. And so a Dyson sphere would give off an unambiguous signal of infrared radiation in a very strange way that would be perceptible. But a Kardashev 3 civilization that had moved around all of the stars of their entire galaxy and enclosed them all in Dyson spheres would be even more obvious. So I think that we are, when you think about like the tools that are available for us to be able to search for some kind of evidence are actually pretty significant. And then it always comes back to the Fermi Paradox, where you're just like, where is everybody?
Yeah. I know one of the ones people always like to suggest on the channel when we discuss the Fermi Paradox is, could those voids, or could dark matter or something like that, all be a K2 or K3 civilization? And that waste heat problem never really tracks for a lot of folks. And of course, maybe someone finds some way to break the laws of thermodynamics down the road for a free lunch. Besides radio signals and waste heat, has anybody suggested any other good ways of finding one? I'd imagine Jason Wright might have put up megastructures around stars.
Yeah. Well, it was funny. I just did an interview with Jason Wright, and he admitted that he was the one who put the idea of megastructures into everybody's brains. And he's unapologetic about it too. But I mean, obviously there is the direct transmissions, right? You're looking at, say, a radio transmission or an optical transmission, or some more exotic particle like a neutrino or something that they could use to try and communicate with us. But the other thing that we can always look for is transit. So you mentioned megastructures, where we have these really sophisticated tools that are designed to watch planets passing in front of their stars, and they see this unambiguous signal that a planet is passing in front of the star, dimming the light from the star, and then reappearing, and then the light reappears as the planet moves away. And you can actually find this stuff with your own telescope. You can confirm exoplanet discoveries with a fairly small telescope. There's some great tutorials on YouTube and online if you want to do that. But if you had something that was like the shape of a triangle or some other shape, some kind of clearly artificial shape, it would give a very different light curve than a nice round spherical planet. And so that's one of the other ways that they propose to be able to look for some kind of evidence. And then the other one, of course, is just the idea that there are historical artifacts here in our own solar system that the alien civilizations left here. They sent their robotic factories to the solar system. They produced a bunch of monoliths and then spread them around on the moon and on Earth and on Europa. And it's just a matter of time for us to find them. And we just haven't mapped the worlds in the solar system to a level of resolution yet that we would notice these things if they weren't a kilometer across in many cases. I mean, Mars has been pretty well mapped, and the moon, but if you had something that was a kilometer across, it could still be hiding on Europa, and we wouldn't even notice.
That's a pretty good example of these, but you might have a probe come into the solar system, say, one that was looping around the star on a hyperbolic trajectory.
Yes.
So,
yeah.
I would not mention the name of that asteroid because I always botch the pronunciation of it, but what do you think of that? Oumuamua, yes.
Yeah, well, I mean, that idea, I mean, of course it's a rock, right? Of course it's a rock, or of course it's a comet, or it's a smashed up comet, or it's a smashed up rock, or it's a rock, or it's a comet, or whatever it is. It's probably not natural. But, and in fact, like I said, there's some interesting research that just came out that, yeah, maybe it could be it as it crossed past the sun, got smashed up into a longer shape that is a debris that, cloud that is rotating, which gives it that more elongated shape. So there's a lot of natural explanations for what Oumuamua could be, but just this idea that a rock can make the trip from star to star, so it doesn't seem super weird that some future civilization is going to be able to develop the technology to be able to travel from star to star. You know, we're smarter than a rock, I think. And so we can imagine some future civilization pulling this off, probably by using a rock.
Well, I was thinking, many people wonder on things like this when we talk about, well, maybe it's a solar sail, what shape it is. And I was thinking back to New Year's when we were watching Ultima Thule get a little bit bigger on the screen, going from 1 pixel to 2 pixels. Yeah. And folks will wonder, why don't you guys just take a look at it? Why can't we see it better? And it's so hard to explain, you know, why can't we get a better photograph of these things?
Yeah, well, I mean, and like Oumuamua is a great example of this. Like, it's coming in at such a fast velocity that it is on an escape trajectory back out of the solar system. It is not here to stay. And that velocity is theoretically possible for us to achieve with some of the fastest spacecraft that we have. When you look at the Delta IV Heavy that carried the Parker Solar Probe to the sun, which is the hardest place to reach in the solar system, or the Falcon Heavy that's that has already launched. You know, if you put a teeny tiny probe on top of a Falcon Heavy, you could probably catch up with Oumuamua, but it would take several years, and every month that goes by, it adds years to the time you actually meet up with it. And but it's entirely possible that we could start constructing a probe today, be done within 2 years, say, launch it on a Falcon Heavy or a Delta IV Heavy, and catch up with Oumuamua in, say, 10 to 15 years, and take close-up pictures and study it and analyze it, and because it's going to be going through the solar system for the next 10,000 years still, even though it's going so fast.
So it's always one of those questions of how big the solar system is. And we were just talking a moment ago about New Horizons and Ultima Thule, and people say, well, this one's leaving the solar system. And they say, where exactly is the edge of the solar system? And all those small little dwarf planets out there we keep discovering on the edge of it seem to say there's more territory out there, not just empty space. So
yeah, I guess you got to define edge, right? Like, is it the heliosphere? Is it the Kuiper Belt? Is it the Oort cloud? Because, I mean, the Oort cloud probably extends out about 50,000 astronomical units, like halfway between us and Alpha Centauri. So the solar system is actually pretty big.
And we have yet to even catalog a small portion of these, which is why it's so, we're lucky. We're very lucky to have found that asteroid as it came into our system, but we did that because it was getting so close to our own sun. And yet,
close to the Earth.
An awful lot of these smaller asteroids, that we really can't see that well. We can only see them as like 1 pixel. When people get surprised, they find out that these aren't always being discovered by these giant universities and observatories, but are often taking place in someone's backyard where the first discoveries happen.
Yeah, I mean, space is big. And even just the amount of degrees in the sky across the entire sky that we can see, it's a huge area to resolve at a high level of detail. And so a lot of amateurs are able to really contribute to the field of astronomy by pointing their telescopes up into the sky and analyzing a tiny little spot in space night after night after night, looking at different areas. And a lot can discover asteroids and find supernovae and confirm, and you can find exoplanets for gravitational microlensing events. So it's quite amazing how kind of like how undiscovered space really is. We know where all the stars are, we know where all the permanent objects are, but to find the things that change, the really exciting stuff, that's a constant job, and a lot of people are able to participate in that.
If folks were interested in getting started on trying to do that themselves, though, they presumably need to do something a little bit more upgraded than just going to the store and buying a telescope for a hobbyist, right?
Well, it depends on what you want to do. So, like finding exoplanets using either if you want to confirm transiting exoplanets, you don't need that big of a telescope, an 8-inch, 6-inch telescope, an 8-inch telescope. You need to have a nice camera attached to your telescope so that you can do photometry. You can measure the brightness of the stars that over time, so you can confirm that the planet is there. With these gravitational microlensing events, same thing, fairly small telescope. You just need to be able to have a nice camera attached to it that you can confirm a light curve that you're seeing.
I'd be remiss if I didn't. The thought had come into my head recently because I was looking through the book that you recently wrote with David Dickinson on basically how to get used to doing astronomy at home. And one of my favorite bits in there is how to build your own $500 observatory in your backyard. And
yeah.
So I was flipping through it earlier today. Let me pop that up there real quick so people can see it.
There you go.
And
twinsies.
Oh, there we go. And it is surprising because, I got my start doing astronomy at a local observatory that we had gotten, which was fairly useless in Ohio, to be honest, but it was a very nice telescope. And I was one stuck doing the shows for people on Friday nights when it was open to the public. So my greatest fun was rotating the dome on people in the dark so they could suddenly jump and be scared. But it is just amazing how much just in the last 20 or 30 years it's gotten so much easier to do top quality astronomy. Is that kind of why you got into dividing that book, or?
Yeah, well, I mean, I think that a lot of the material that was out there was sort of stuck in the past. That a lot of the people see this astronomy as this sort of solo thing where you go to the store and you buy a telescope and you take it outside and you look through it and you see some stuff and then you put it in the closet and it collects dust. And there are so many things that you can observe now and so many great tools and techniques that you can use that we wanted to bring a lot of that modern thinking into what we did. Like even with all the photographs, all of the photographs in the book are done by amateurs. We reached out. I mean, it's very easy to get access to Hubble Space Telescope pictures. I'm sure you use them for your videos, but not everybody has access to a Hubble Space Telescope in their backyard. And so we wanted to show what a regular person with skill and technique can pull off. And so we've got shots of all the planets. We've got shots of the International Space Station that one astronomer was able to capture, the sun, the moon, and then of course all these wonderful deep sky objects and long exposure stuff. And wanted to try and make this hobby so accessible and help people, give people those first steps they need to take to be able to get into this hobby seriously. And I like astronomy. I mean, I love astronomy. Just, I love looking through a telescope. I'm always thrilled when I can see Saturn or Jupiter or the moon. It always blows your mind. And I love to be there when you show it to another person. And I'm sure you got that when you were working the observatory and you're like, okay, let's put it at Saturn. And then people looking through and they're like, no way. That's Saturn? Really?
It is so much different to seeing them, right through the lens the first time as opposed to, we get so many great artistic renderings and photographs, but there really is a big difference doing it in person. And I think we will tell people there's a lot you can do with amateur astronomy and, you could discover an exoplanet or an asteroid, but I think they sometimes assume that's a rare lucky strike, whereas if you're actually doing this with a halfway decent amateur telescope, you are going to find one of these things. It's not a
Oh
lot of the
yeah,
odds chance. It's
yeah,
practically a guarantee.
yeah. Build up your skills, learn the techniques, and then just put in the time and be out there on a regular basis, and you will find them. There's a supernova hunter uh, out of Australia who
Discovered a lot
has
of them.
found hundreds of supernovae. He knows his galaxies. He takes his telescope out every night and he just keeps scanning all of these galaxies that he knows, waiting to see one pop with a supernova, and it's just a matter of time. We discovered a supernova in one of our virtual star parties by accident. We didn't realize that we had a supernova, and our one of the people who was in the star party with us said, "Oh, that galaxy often has supernova in it. Doesn't have one right now." And then, of course, what do you know? It did. And then the next morning, it was announced that the supernova had been discovered, and we missed it. But we had a picture of the supernova, and we were able to provide to the scientists our images of it. But it's kind of amazing to think that regular people, just with some time and patience and skill, can contribute to the science and be a part of this.
And of course, usually we mean visual telescopes as opposed to ones in different frequencies. But do you ever see that becoming a big amateur area, infrared or radio telescopes?
Well, I mean, it's tough. Like, a radio telescope is a different creature, and the problem for most, like, if you build a radio, you can absolutely build a radio telescope. You can turn a radio, like an old satellite dish, into a radio telescope. But it's a very I don't know. It's like, when you do it, it has like a 1 pixel of resolution, and so you're pointing your telescope at some radio source, and you get, yes, there is radio waves there, and then you turn a little to the side and you're like, no, there is not radio there, and you can kind of go like, oh, we're getting a radio frequency of this. Like, you don't get those pretty pictures. And I think that for a lot of people to be able to look at the eyepiece, look at the pictures that are coming off their camera, and go, oh yeah, I see it, is worth it.
I think that definitely is a lot more the appeal, though. But I guess they do that SETI crowdsourcing project. I guess that could be argued to kind of be radio telescopes.
Yeah, well, you're crunching data, right?
Yeah.
Which is a much needed assistance. So for the people who are running the SETI at home and the BOINC project, if you wonder if you're helping, you're totally helping. It's way too much data. They pull out terabytes and terabytes of data on a fairly short observing run, and then they need people's help combing through all that data to search for anything they can find.
Come to think of it, wasn't Tabby Star, we were talking about megastructures and Tabby Star a moment ago, wasn't that how they grabbed that one as well? Amateurs had picked up from the data?
Yeah. So I think it was done through Galaxy Zoo, I think, and it's the situation where you've got amateurs scanning through tons and tons of photographs and data, the kinds of projects that computers are really bad at, and they're finding these weird things, and then they pass these along to the scientists. They're like, I found a weird thing, what is it? And then the scientists have a chance to look at it and try to categorize it. And Tabby Star was so weird that a lot of scientists jumped onto it and are continuing to puzzle it out even now.
I guess that anomaly hunting is probably what pretty much describes most science going back. I would say probably Galileo was a little surprised when he got zoomed in on Saturn and saw the weird little thing sticking off the side of it.
Yeah, exactly. It's this funny. Was it Asimov who said, the most interesting thing that you can hear a scientist say, or is like, that's funny, that's weird. Right? Like, that's what you wanted. That's when you're onto a real scientific discovery. When you don't
have that moment where you look at it and say, what was that? That can't be right.
This? Yeah, this is unexpected. Yeah, absolutely.
But I guess we have, we certainly have these projects that are deliberately looking for things. We are bemoaning the James Webb Telescope never quite launching a little bit ago. What would you see after this next upcoming generation of telescopes? What would you see as the best area to concentrate to in terms of these bigger telescopes that we do as massive projects?
Well, we are right around the corner from 3 gigantic telescopes that are under construction just on the ground. Well, 4. The first one's going to come online is the Large Synoptic Survey Telescope, and this is a telescope that's going to be scanning the night sky night after night after night very quickly. And it's the machine that's going to be doing things like finding those asteroids, those comets, those supernovae, and weird things that space does when we're not looking. And that's due for first light in just a couple of years now. So we're really just around the corner from that. And that's going to be down in Chile. There's going to be the giant Magellan Telescope, which is going to be, I believe, a 28 meter telescope. I forget the exact size. And then there's the 30-meter telescope, which is going to be built in Hawaii. And then the monstrous one of them all is going to be the extremely large telescope, which is the sequel to the Very Large Telescope, which is the European Southern Observatory. And it's going to be 39 meters. And it will have the resolution to image, again, to directly image the atmospheres of planets orbiting other stars. That we will have on the ground a telescope capable of doing this kind of stuff. That will match and exceed the power of the best space telescopes that we have right now and into the foreseeable future. So I think just on the, but then in space, we've got a bunch of gigantic telescopes coming there. We've got WFIRST, which is going to be sort of like Hubble, but it's going to be it's going to be a lot faster and a much wider field of view. And again, looking for things that are changing. Of course, James Webb, which will launch in the year 8000. And then there's a bunch of next generation telescopes that are in the thought process right now. The best of these, the one that I really want to happen, is LUVOIR, the Large Ultraviolet Infrared Observatory, which is going to be a 15 to 18 meter space telescope, sort of at the very limit of what can be launched by an SLS with a full Block 2 upgrade. Or the other idea is to launch it in pieces and assemble it in some space station. And when you think like the biggest telescopes on Earth today, maybe you've got like about an 11 meter telescope or 10.4 meter telescope.
I think that's what Subaru.
The Grand Carina, the one on the Canary Islands. And then you've got the Very Large Telescope is 4 separate 8.4 meter telescopes. And then I mentioned these next generation ones that are coming. This is going to be of that same scale, but in space. And so it's going to be able to do things like it'll be this wide spectrum like Hubble. Like Hubble's this really special instrument because it does from ultraviolet through to infrared and through the visual spectrum and the visible light. And so James Webb is a completely different spectrum. It's looking at really cold objects. And when Hubble goes, we won't have a space telescope that's in that same field. And that's what LUVOIR is going to do, is be there. And I had a chance to chat with one of the researchers with LUVOIR, and one of the things that he said is like, again, it will be able to image the atmospheres of planets going around other stars, and it will be able to look with such sensitivity to such a distance to tell us with about a 90% accuracy whether we're alone in the Milky Way. Like you don't see any life on all these planets and all these stars to this far of a sphere around us. And then you go, we're probably alone. Or, how much life there is. You can measure it.
So you think inside 20 years we might have an answer to the Fermi Paradox, or is it probably still a little bit too much to guess?
Yeah, I think so. I think we've got enough interesting things going on when you think of what's happening here in the solar system with the exploration of Mars and the potential missions going to Europa and Enceladus and Titan, all these places where you would expect to find life. If there is life in the solar system, these are the places you'll find it. And then you've got all the work that's being done on SETI, searching for techno signatures, from radio to laser to transits to infrared, looking for type 3 civilizations, et cetera, et cetera. And then you've got the work in infrared and optical, analyzing, looking for biosignatures. That is like a full court press, that they are trying to find evidence of life across every method that's available to them. And I think that, I think we will have an answer. I mean, obviously you can never, you can't prove a negative, right? But at a certain point you can say, we've scoured the solar system and we found nothing. We've scoured our local sphere of the Milky Way and we found nothing. We've analyzed to our satisfaction every single galaxy that we can get our eyes on, and we haven't seen any evidence that there's a Type 3 civilization out there. We have scanned the Milky Way, and we don't see any Dyson spheres. We are looking for transiting megastructures, and we haven't found anything. I think at that point, the harsh reality that we are alone in the Milky Way will just become more and more of a central idea. And then, as we talked about in the beginning, then the responsibility is on us to take care of this planet and to make sure that we get our shot to help spread life out into the universe.
I guess I'll ask, we on that front, people always say the moon or Mars or maybe Venus first. Yeah. Fraser Cain, which one would you go for first? Unlimited budget.
None of those. None of the above. I always say that gravity wells are for suckers. And so, if you go to all that energy to get out of a gravity well, don't go into another gravity well, right? They're traps. So I think the best thing that we'll be able to do is to learn to live in space itself. Like, I think we will absolutely go and set foot on the moon and kick a couple of rocks around and see what we can find. We will absolutely do some exploration on Mars and probably in Venus as well. But I think the heavy lifting of space exploration is going to be the asteroids. That we're going to drill into them, we're going to build habitats, we're going to spin them up, we're going to use the resources because their gravity wells are so low, they're really easy to shift resources around from world to world. And I actually really think that when we get really excited about just the kinds of launch platforms that are coming around right now, we think about the Falcon Heavies and we think about the Super Heavy and the Starship, which I'm still trying to wrap my head around saying. This comes from this mindset that we're going to want to launch a bunch of stuff from Earth. But the reality is, of course, 20 years, 30 years, 40 years from now, we will have the infrastructure in space to harvest the resources that we need to make whatever we want in space. There will be no need to launch anything from Earth. Like, the only reason you'll have tiny rockets that will launch just us, just the meat into space, and then you'll go up to the space station, and then the robots will be arriving with the 3D printed space station trusses and stuff that have come from mining the asteroids. Like, I really think that we're in this tiny phase of our space exploration efforts where we think that it's important that we're going to need to launch a lot of stuff from Earth. Eventually we won't. We'll need to launch anything from Earth apart from us on our tourist flights. So no, I wouldn't go to any of them. I don't think any of them are long-term viable places. Venus is the worst, right? Obviously. And, what does it have going for it? It has Earth gravity. And obviously if you fly around in your floating cloud city, then you get to have Earth temperature and Earth pressure, but you also still have to breathe. You're going to need
float around in a sea of acid.
And it rains sulfuric acid and so on, right? So it's not great, and there's no place to stand. Mars is dry and cold and almost airless, and the radiation is intense, and we don't know what low gravity is going to do to the human body over the long time and over multiple generations. We don't. It could be a crime against humanity to let people give birth on the moon or Mars, and the moon could be even worse, with even less resources and even less gravity and even harsher radiation that's coming to it from space. So I think all of them are poor compared to us being able to take an asteroid, spin it up, live inside, get the kind of gravity that you want, have the protection from radiation, have access to resources, and the delta V's that you need to move stuff around the solar system is fairly low. So that's none of the above. Let's just go to space itself.
I like the comparison there with going from basically one bad relationship to another when you're leaving the gravity well and just jumping into another one.
Yeah, don't go to another. You did it. You made it. You escaped a gravity well.
Stay out.
Don't go back. Don't go back to another gravity well.
Planetary counseling. So of course the option there is you start harvesting all those asteroids up to build yourself a K2 or Dyson sphere civilization. one of the many great episodes on Universe Today, of course, being that collaboration we did discussing Cover Show 2 Civilizations. And, of course, the other one we had on colonizing the solar system quite some time back. So, if you haven't already checked out Fraser Cain's channel on Universe Today, or the publication Universe Today, or the book, they're all going to be links for them below in the video description. And, of course, he was good enough to join us on this channel, but on his channel he regularly interviews some of the top minds of our profession. So make sure to check them out, and we are glad to have had you here today, and we will see you on Thursday.
Anytime you want to do anything, Isaac, you let me know. I'm on board. Thanks for having me.